In this video, I'm going to introduce you to DeepSparse. DeepSparse aims to accelerate inference for deep learning models on CPUs using neural network sparsity. Normally, what happens is that deploying deep learning models on CPUs has meant compromising speed for scalability and flexibility. DeepSparse support for efficient inference on CPU means that you can deploy performant models without being tied to accelerators, which results in cost reduction, and also it reduces the barriers to entry in developing machine learning applications. The way it works is quite interesting. It uses sparse kernels, and through sparse kernels, 8-bit quantization, pruning, and intelligent caching of attention keys values, the library enables GPU-like inference speed for LLMs on commodity CPUs. They also have a very cool paper which you can read here, and I'll drop the link in video's description, and you can also download this paper from the right. If you go through this paper, there are three salient features which stand out. First is the broad model compatibility. So this technique supports LLMs, BERT, VIT, ResNet, and other popular architectures, which is good. Then it is also very adaptable across various hardware from cloud to edge, and it also gets seamlessly integrated with a lot of things which reduces deployment complexities and compatibility issues. Now we can easily run it on any CPU enabled server, and let me show you how. I will be using Google Colab for this. The first thing we need to do is use pip to install this DeepSparse, and I'm just using it with LLM for now just to make it easier and quicker. Let's run it and wait for it to finish downloading. Shouldn't take too long. I think in my experiments normally it takes around 2 minutes, so let's wait for it to finish. It has started downloading. Library has been installed. Now in order to run our model on CPU with CPU inference, all we need to do is this. We are importing the text generation from DeepSpark. We are specifying our quantized model, which is in this case is MPT7B Dolly, and then we are giving it the prompt in this way. And we are passing some of the hyperparameters. If you scroll to right, after specifying this prompt template, this is what I'm asking this model. What is the capital of Australia? And then it will print the response. Let's run it. So first it is going to download the model and a few other things like config and quantized version, and then it will run it. So let's wait for it to finish. And as it is a quantized version, so I believe shouldn't be more than 6 GB per file. So let's see how it goes. It has started downloading. I hope that my Google Colab would be able to accommodate this. So you can see that the first file is around 6.39 gig. So let's wait for it to finish. It is still progressing, and the first file is almost done. And then it is going to do some overwriting on this subject files, which is fine. And then it is downloading the model data now. So let's see. Let's wait for this one to finish. ETA is around 5 minutes, I would say. The second file is still being downloaded. While it downloads, let me quickly show you the paper where they have described the methodology for the sparse fine tuning. And it is quite interesting. So this is how they are doing this sparsification. So to obtain a set of sparse models satisfying target compression requirement, what they are doing is they have increased the sparsity level gradually while fine tuning the model on task of interest. So they have started from a list of desired sparsity level in increasing order, and then they iteratively prune and fine tune the model while following the original fine tuning recipe in each subsequent cycle. Very, very interesting. And because we already know that fine tuning and training the model is still quite not only expensive but difficult, and we never know how it is going to turn out. So when we follow this iterative approach with sparsity level gradual increase, then the performance becomes quite better and the process becomes somewhat easier. Okay, now let's check our Google Colab again. So the second file is downloaded and now it is giving us some of the info where it is overwriting in place. And I think this is where we just saw the sparsity level increase. It is giving us some of the warnings that the memory consumption might increase. And you can see on the top right that there is a spike in the memory in your Google Colab. So I hope that it is able to deal with it. So let's see. Let's wait for it to finish and come back. Okay, in this step, it is overwriting the input shapes of the transformer models on top of the model, as you can see in the last line here. There you go on this ONNX model. So while it happens, because this is going to take some time, let me show you a couple of applications of this sparse fine tuning. So if you go to the paper, this is one application which is compression of T5 and whisper translation models. And then they have considered various sparsity levels corresponding to ranging from 2 to 8 and then also to the 10 one. And then they have applied it uniformly per layer with sparse GPT pruner. And then you can read more about it. Another application which they have mentioned, which is quite interesting, is this one, compression of generative model. And I think this is more like which is going to be incorporated in the models going forward in few of the models, I believe, especially this MPT family. So because this is one of the requirement I am seeing from more and more companies where they want to compress the generative model because some of the sizes are huge. Now they have also put in some of the accuracy results for different losses in this figure, and if you look at this, they show very similar trend to the other application, and you can read more about it because I don't want to go into this more detail, but very interesting read, especially this is a new thing where they are not only showing the research but also showing the application of it. Cool. Let's go check our Google Colab how it is doing. It is still working. I'll wait some more time for it to come back and I'll pause the video. But I think generally we know how to use the sparse fine tuning, and because it's a free version of Google Colab, so it is understandable that it is taking this much time. Let's wait for some time to see if it comes back. So I have been waiting for this to finish for the last, I guess, 15, 20 minutes, and it is still taking a bit of a time. And you can see on the top right that my memory is really spiking. So I will just let it run for some time, and I believe it should finish in some time. And you can try this out on your own local system, and I will share the link to the repo in video's description. Before I finish this video, let me show you quickly one more thing that they have also mentioned that for the first time they are they have shown that the sparse fine tuning can reach 75% sparsity without accuracy drop. Now this is quite a huge claim and I would really love to test it out, and I'm just wishing that this Google Colab would come back as soon as possible, but doesn't seem it would anytime soon. So if you manage to test it out and if you see that 75% or even closer sparsity, please share them in the comments. I'll be very obliged. And if you like the content, then please consider subscribing to the channel. Thank you very much and enjoy your day.